This 2022 paper 1 question 9, we're given a function here to show how much is left after t days. So we're asked how much is left after 2.5 days. So we just plug in t equals 2.5. We'll get 15 times 0.6 to the power of 2.5. And that is equal to, you'll get about 4.182. 2 decimal places, it'll be 4.18. And remember, the unit is milligrams. We're told that in the question. Then we're asked after how long will there be 1 milligram left. So basically 15 times 0.6 to the power of t, that's how many milligrams are left after t days, and we want that to be equal to 1. So we just need to solve this. So we can say that 0.6 to the power of t is equal to 1 over 15. And then you can just apply log base 0.6 to both sides. 0.6. And on this side, you do the same thing. Log base 0.6, and they cancel on the left side, giving us t is equal to log base 0.6 of 1 over 15. You can use log with any base and then bring the t down to the front using that rule of logarithms, whatever way you want to do it. But when you put that into your calculator, you should end up getting 5.3 days. And remember your 1 decimal place, so there we go. So then he gets the drug every day. So we're asked to explain why this is how much of the drug is in his body. So the idea is for the injection he just got, there's going to be 15 in his bloodstream because that's he just got it, and that's how much is in the injection. And then the one from the day before, we're told in the question that the amount in his body decreases by 40% each day. So from the day before, this 15 has decreased by 40%, so only 60% is left. From the day before, we had the 15, and it's decreased by 40% twice. So we're kind of multiplying it by 0.6. So basically, we lose that 40%, and then the day after, we lose 40% of that. So that's why we're multiplying by 0.6 twice, and then the same argument for this. So that's what they had in the marking scheme. That's kind of... So you can explain what each term means, or you can explain why these are the terms. So yeah, it's kind of the stuff that I just said, that it's going to be decreasing by 0.4 every day. So for example, the one you got 4 days ago, or that's going to have decreased by 15 3 times because it's been in his body for 3 full days. Then we're asked to find how much is in his body after 10 days. So if this is how much is after 4 days, well then after 10 days, we'll have 15 plus 15 times 0.6 plus 15 times 0.6 squared plus ... And you can see for 4 days, the highest power is 3. So for 10 days, the highest power will be 9 for that reason. You could put this into your calculator, but it's easier to use a geometric sum. So you can see the first term is equal to 15, and the common ratio is equal to 0.6. So the sum of the first 10 terms, there's a formula in the tables booklet, and the formula looks like this. So we do have n equals 10. So we'll have 15 times 1 minus 0.6 to the power of 10, all over 1 minus 0.6. And you can just put that into your calculator, and what you should get is 37.273 ... It keeps going, and it has 2 decimal places, so it's going to be 37.27, and we're in milligrams because that's the units of the injections. So then we're asked to use the sum to infinity to figure out how much is going to be in his body after a long period of time. So there's a formula for that as well. Or another way you can think about it is, remember that r is going to be less than 1. Well, the absolute value of r is less than 1. So this number, when n gets really big, up to infinity, this number here gets very close to 0. Because if you have a number that's less than 1, so like 0 point something or minus 0 point something, whenever you increase the power, it gets smaller and smaller. So that goes to 0. But there is a formula in the tables book as well, which looks like this. And that's just because this r to the power of n term is equal to 0. So that's how it simplifies. So we'll get 15 divided by 1 minus 0.6. And you can put that into your calculator. And what you should get is 37.5 milligrams. So then we're told about different injections. So she gets d milligrams, and it decreases by 15%. And we're asked to show that this is the formula for how much is in her body. So similar as the last time. So the most recent injection will just be d. So that's kind of like the most recent injection. You can say that's the first one. The second injection will be d times 0.85. So that's yesterday's injection is decreased by 15%. That's the second one. The third one will be d times 0.85 squared. And notice that this is the third one, but we have a 2 in the power. So if we're going up to the nth one, we're going to have 0.85 n minus 1 in the power, because you can see that the power is 1 less each time. Same logic as one of the previous questions we did up there. So now we just need to figure out what this is. So we need to add all these up to find the total amount in our bloodstream from all of the injections. So we'll do Sn equals, and then we use the formula from above. That's this one. So the first term is D, 1 minus, and the common ratio is 0.85. That's to the power of n, because we're adding up the first n terms. Because even though the power here is n minus 1, this is the nth term. And the reason for that is because the nth term of a geometric sequence is a times r to the power of n minus 1, if you're starting at 1. And then we divide that by 1 minus 0.85. And then 1 minus 0.85 simplifies to 20 over 3. So that just becomes 20 over 3 times this thing. And then all they did is they just combined it into one fraction, kind of like this. So yeah, that's where that comes from. Then finally, we're told after the 7th injection, there's 50 milligrams in the body, how much of the drug is in the daily injections. So basically, n is equal to 7, because it's after the 7th injection. So what we're going to end up having is the total amount in our body is going to be 20d times 1 minus 0.85 to the power of 7, all divided by, just divided by 3, and that's equal to 50. We know that. After the 7th injection. Now we can just solve for d. So d will be equal to, multiply the 3 up, we get 3 times 50, and then we can divide by 20 times 1 minus 0.85 to the power of 7, and you can just put that whole thing into your calculator, and what you'll end up getting is 11.03, but then to the nearest milligram that'll be 11 milligrams, which is what they asked for.